This video talks about absolute value inequalities. So let's talk about the equations a little bit. We discovered that in an equation there's one specific value that will make the statement true. In this equation we have x plus 4 equals 12, and if that's the case there's only one number that will make that true, and it is 8. And we write that solution set with the curly brackets as that one number that will satisfy those requirements. In an absolute value equation, we've learned that there are two values of x that will make the statement true. And here, if I have the absolute value of x plus 4 equals 12, by working this out algebraically, we'll discover that x can equal either negative 16 or 8. And by plugging them in we prove it. I'm going to write that solution set like this. And again, because it's an equation, there's a specific pair of numbers that will make that work. And I use the curly brackets to show that. So now we're going to talk about inequalities. And with an inequality, there's a range of values that are going to make the statement true. If I tell you that x plus 4 is greater than 12, then x can be any number that is greater than 8 because, for example, 9 plus 4 is greater than 12 and infinity plus 4 is greater than 12. But let's find this out on the number line. So here, if I'm going to say that this is 0, I would write that as, here's 8. Now 8 won't actually work because 8 plus 4 is 12. It's not greater than 12. But any number that is greater than that, all the way through to infinity, will work. So I'm going to write that solution set in interval notation as parentheses 8, comma, infinity parentheses. And I want you to remember, if it's only greater than, you use the parentheses. If it's greater than or equal to, then you use brackets, and we'll remind you of that a lot more. So that's the idea of an inequality with just a normal, regular equation or expression. So now let's talk about what it looks like with an inequality. Now, just like with an equation, there are two cases that can occur. Here's the absolute value is greater than a value. So I'd have the absolute value of x is greater than 5. Or I could have the absolute value is less than a value. So the absolute value of m is less than 4. In both cases, we're going to solve these using partner equations. Remember, that'll be x is greater than one thing and x is like that. So there's two branches off each one. So let's look at the less than scenario first. And this is probably the more complicated of the two, in the sense that there's several ways to do it. And I'm going off changing things from the book a little bit for now. I want you to get the basics, and then I'll show you a speedier way to do it later. So here we have an inequality that says x plus 4 is less than 5. And that states that the absolute value of the expression x plus 4 is less than 5 steps from 0. So here's 5, and we know from our other work that that will also be the case. So somehow x plus 4 works for this, and x plus 4 works for that. And this is just the setup number line, sort of helping you visualize what that's going to look like. So somehow our x is in between the values. That's something to think about. So there's a couple of things here. So we can set this up as partner equations just like we've always done. I have, and I did it backwards on this one, I wish I hadn't. So here I have the original equation was the absolute value of x plus 4 was less than 5. So all I did right here was I just copied it, took out the bars. So there's the original equation. And then I took it and I flipped it, because remember we have to take care of this part. And what you do when you write that, you write the original expression and then you flip. Here it's less than, I'm going to make it greater than negative 5. So flip opposite. Flip up. And then to solve algebraically, we'd take 4 from each side and we'd end up with x is less than 1. So there's my 1. And that looks like that. And it'll go from 1 to infinity, negative infinity. Right? And on this side, I have x is greater than negative 9. Here's negative 9. And it'll go from negative 9 all the way to infinity. The only problem is I have to have both of these things be true. So it only works between those two numbers. And that's important. So because if I tried one of these numbers out here, it wouldn't work. If I tried one of these numbers out here, it wouldn't work. It will only work for both of them if we do that. So here's where x is true. So x works between negative 9 and 1. And because it's just greater, I'm going to use my soft brackets, use parentheses. I'm going to do this again, so if I went too fast, it's okay, just relax. First of all, let's just take a look at this very quickly. This is just sort of the idea of a very simple one. So here I have u is less than 9. So here I'm going to say, I'm going to write it as it is, u is less than 9. And on the negative side, I'm going to write u is flip it, negative it. That's not a verb. So let's do it here. So here's negative 9, and here's positive 9. And you notice I made circles because it's just greater than, so it's open. And I know that my eventual answer will be like that. So here, it's any number that's greater than that. And here, it's any number that's less than that. But we have to have them both. So it's the numbers that lie between that and that. So my answer would be negative 9, comma 9. And again, anything out here won't work, and anything out here won't work. So this one is a little more complicated. First of all, there's no, I'm ready to go. There's no constants hanging around. I can just go right to this. I'm going to do my negative side first. So write 4 minus 5p as it is. Flip it, opposite, and I'll be good to go. For the positive side, I get to just write it as it is. Whoops. Okay. So let's do this algebraically. So here I'm going to take the opposite from that, and I'll have negative 5p is greater than negative 20. And here I'm going to do the same thing, and I'll have negative 5p is less than 12. Now, this is going to be one of those weird important moments in inequalities. I have to divide this by negative 5 to get p alone. And when you're working with inequalities and you divide by a negative or multiply, you flip the sign. the operator, sorry. So here I'm going to have P is less than 4. I switched it because I used a negative, and a negative divided by a negative will be a positive. I'm doing the same thing over here, dividing by -5, so I have to flip the sign, so I'll have P is greater than -12/5. So I'm going to graph that and see what happens. So P is less than 4. I'm going to find 4. And -12/5 is about not quite 3. So 2 and some change. So I'm going to put it right there. So let's see. It is greater than that, right? And it is less than that. So it lies between here and here. So -12/5, comma 4. And that's going to go in here. -12/5, comma 4. Okay. Here's one that's slightly different. It's just a greater than or equal than sign. We're going to do exactly the same thing we did before. We're going to do our partner equations. So here I have 6k plus 5 flip, opposite. And here I have 6k plus 5 leave it, leave it. I'm going to solve algebraically. That'll give me 6k is greater than or equal to -18. And here I have 6k is less than or equal to 8. Divide by 6. K is greater than or equal to -3. K and K is less than or equal to 4/3. So again, I'm going to graph that. First I'm going to find -3. Watch this. This is greater than or equal to, so it's a solid dot. And here I have 4/3, which is a little bit more than 1. So I have a solid dot. And because it's and, the answer is the numbers in between. So here the range is from -3 to +1. Again, pause to copy. Now, I have some silly ways that I remember this. If it's a less than sign, less than or equal to, it's an and equation, and I remember it as less than and the and. I know it's pretty hokey, but think about it this way too, that the inequality points inward. It's inside, so it points that way. And basically the solution set overlaps. It's this, and where they meet. Again, if you need to pause to copy that. Like I say, whatever works for you to help you remember, but I would really suggest making some kind of mental trick to do it. Now, there is a speedier way to handle a less than absolute value inequality. They go over it in the book. I'm going to treat that in a separate video called Compound Inequalities, which you'll find in this unit. That's it for now.